Hi and welcome to Kirti's Learning Factory. Today we are going to learn a few more things on remainder theorem. Today we are going to learn how to deal with higher powers. Okay, and this is not the only way to deal with higher powers, but I'm just going to bring about a certain expression, a certain method which will help you kind of deal with it better. See, any expression in remainder theorem, if you're asked, if you can possibly express it, say as ax plus 1, okay, raised to the power n divided by a. If you are able to write any expression in this way, the remainder, it is always going to be 1. And obviously, it's quite simple, right? Because ax by a will be totally divisible, the remainder will be 0. And 1 by a, the remainder will be 1. And it doesn't matter how many times you multiply with 1, uh, in the end, you will only get 1. So if you are able to write the expression as ax plus 1 by a, it doesn't matter what the power is. The end remainder will always be 1. Okay, so that's one. And then number 2, say for example, if you are able to write the expression as ax minus 1, okay, raised to the power n. In that case, then there are two scenarios. If n is odd, okay, and if n is even. If n is even, then the remainder obviously, because see, it is minus 1. Minus 1 raised to the power even numbers, even times. So it will become 1. So the remainder will be 1. Similarly, minus 1, when it is raised to the power n and n is odd, it will be minus 1. So that's how the remainders will vary. When the expression can be written as ax minus 1 divided by a. Just to give you an example, say 37 raised to the power 1085 divided by 9 if you're asked to find the remainder. Now 37, can you not write it as 36 plus 1 by 9? Okay. And this part is obviously raised to the power 1085. Now 36 is totally divisible by 9. So it is nothing but, right? It is 9 into 4 plus 1, okay, raised to the power 1085 divided by 9. Therefore, the remainder in this case, yeah, the remainder, it will be 1. So these are the kind of problems. You will just have to identify that, okay, what is happening. Another example could be, say, 35 divided by 9 raised to the power 2012. Okay. In this case, the remainder is, it is minus, you can basically write it down as 36 minus 1, right? So it is nothing but ax minus 1 divided by a raised to the power n. But because it's an even power, so once again the remainder here in this case will be 1. So that's how you have to then start applying remainder theorem, and you have to see that how do you deal with higher powers. Yeah, only this much for this video. I will capture all these concepts in small bite-sized videos so that it's not too much for one consumption. If you think it is useful, please share it with somebody who might get benefited from it. And thank you for watching. Keep coming back to Kirti's Learning Factory. Thanks a lot.